Okay, let's take a look now at how we could do this hypothesis test using a confidence interval. Let's see what we have here in example 4. Advertisements for a physical fitness center claim that completion of their course will result in a loss of weight. A random sample of recent students revealed the following body weights before and after completion of the course. At the 0.025 level, can it be concluded that the course will result in a significant weight loss? Assume the differences are normally distributed. Okay, so it looks like we have 8 people here that had their weights measured before and after the course, and we're curious if this course can help people lose weight. Okay, so I'm going to start to think about how I could set up my hypotheses here. I know that I'm going to have something with a mu d equals versus something where a mu d is less than something, greater than something, so on and so forth. Remember that when I have this little d in here, that's talking about the differences that I'm going to calculate. So let's suppose, for the sake of argument here, that I am going to do my after minus my before. Okay, maybe that's what I end up with. After minus before. Well, I can see that person A here really did lose weight. They lost a pound. But when I do 154 minus 155, I'm going to get a result of -1. Notice that the same sort of thing happens with person B. When I do the 207 minus the 228, I'm going to get a negative number. So weight loss seems to be corresponding to a negative number coming out of the subtraction. Whereas in person C, where they gained weight, 147 minus 144 is +6, and that corresponds to a weight gain. So I might say something like this. If your mu d is less than 0, then that means that there was weight loss. But if the mu d then was equal to 0, that would be no gain or loss. And so these seem like perfectly reasonable hypotheses to begin to work with. Notice that is going to require that I do afters minus befores when I do my calculations. If you were planning to do before minus after, that's totally fine, but then you would have to flip this inequality symbol because you would be finding that positive numbers correspond to weight loss. Okay, well, let's jump ahead then to the checking of the conditions. I want to build a confidence interval here. So first I'll list out my sample evidence. I can see that I only have 8 people that I'm looking at in this before and after study. And for the rest of stuff, I'm going to just have to enter data into lists. So I'm going to go ahead and do that on the calculator before I go ahead and conduct the checks. So on the calculator, you'll see here that I've already entered all of my values. And so I would encourage you, pause the video so you can make sure to type in all your values, make sure that they match mine. Okay, so if all your values are entered, then we can go ahead up to L3 and we can start to, again, compute the differences. So we don't have to do them by hand. Remember that I said I was going to do L number 2 minus L number 1. And that way all my negative numbers go with people that lost weight, and that +6 corresponds to someone who gained weight. Okay, so now that I have this, I can go ahead and do the checks for building a confidence interval. I'm going to go back to my formula sheet just to make sure that I'm grabbing the right checks. What I'll notice is that the checks are the same as what they were on a regular hypothesis test. So my check is my sample size large enough? It's not. But I'll see up here that the differences are assumed to be normally distributed. So I'll say, assume differences are normally distributed. So that makes my check complete there, and I'm ready to build the confidence interval. And that's what's down here in part of this analyzing of the analyzing of the data. I'm going to need to go ahead and actually think about the fact that my alpha was given as 0.025. So I need to figure out how I turn that into a level of confidence. Again, this is a one-tailed test. And so I know that apparently if I get a value for my average that's too low, I'm going to be concerned. So there should be a value down here, red space, that's 2.5%. Okay? Because again, if it's a one-tailed test, then all of that alpha, all that badness is kind of on that one edge. It doesn't have to be split. But I know that when I put my interval in here, it still has to be symmetrical. So that means that even though I didn't draw it, there's technically another 2.5% floating around over here, which means that my interval covers a grand total of 95%. So I'm going to do a 95% confidence interval and record the result here. I'm going to use a t-interval as suggested by the formula sheet. And again, I'll use the data that I already have. Again, using the numbers from list 3, because that's where the differences are. Fortunately, everything's already set up for me, so I can just go right to calculate. It looks like I get the interval negative 14.94 to negative 0.5617. Okay, so once I actually have these values written out like this, I should be able to go ahead and reach my conclusion. I'm very confident that the differences that I come up with, the average difference, is going to be somewhere between these values. But H0 made a claim about the average difference. It said that the average difference was going to be 0. How do I feel about that now? Well, it seems like the average difference of 0 is not in the interval. And so, based on the evidence, I don't think that H0 is a good fit anymore. So I'll write the following conclusion. Since the believed value of mu d, which is equal to 0, is not in the interval, we will reject H0. H0 doesn't seem like fit. But then we can write our second sentence, which says, therefore, we have enough evidence to believe that, let's see, what did H1 say? Well, it said that the average difference is greater than 0. But if I think about what I wrote in green, it means that completing the course can result, on average, in weight loss. So I'll say the average person will experience weight loss from completing the course. That seems to be perfectly in line with what we had said in this question. Now, sometimes one of the weirdest things to see, and you may have seen it as you practice some of the previous questions, is that depending on how you choose to do your subtractions, you might get very different values back. If on this question you were instead going to do befores minus after, again, you would have a switch in your inequality symbol here, and actually then all of your differences would change, and your interval would change slightly. It would pretty much be the exact same set of values, except pretty much just like positive alternatives. So don't be surprised if you try to do something in one way, and in my solutions I do something different. You should check to see if maybe all of your values are just opposite of what all of my values are. If that's the case, you probably did everything perfectly correct. You just thought about grabbing your differences in a different order. Maybe you did before minus after, and I did after minus before. It doesn't make a difference for the final conclusion, and it would always earn you full credit on a question like that. Okay, well that wraps up section 9.2. Please be sure to practice as much of this as you can in the associated worksheets, and let me know what questions you come across through email or during office hours.